Okay, cool. Now we get into the PhD homework fun stuff. For those who don't know, I'm getting this at UTSA. And my current course is Analysis of Algorithms. Very fun. I already did homework 2. My homework 2 probably bombed, unfortunately. I did it before I actually watched the lectures that it had to do with, and I think I just did it wrong. So I'll have to study that. Dude, I can't. Oh, KO Pyro is now live. Look at that. So my strategy for these homeworks is I'm a very digital person. So what I end up doing is converting it to Word, a Word document, and then I just do it in Word. Back's hurting. I'm gonna lounge. I hope it doesn't make me look fat. Ah. Okay, can you hear me? The course I'm taking right now is Analysis of Algorithms, so it's a lot of like asymptotic proofs and all that fun stuff. Leaning back, my mouse doesn't, or my mic doesn't reach, so we won't lean back. We'll get a crook in our back. I'd like to get some music going, so I'm just gonna do that real quick. Hey, look, I'm live. It's me! Huh, I guess the branding doesn't show. I have a playlist. We'll do this. At least we'll have something Zelda themed going on while I do homework. Oh, you can't even hear that. Very soothing Zelda music. Alright. Oh man, already into the master method. It's gonna make me pull up the textbook? Well, that's mean. I haven't looked at the textbook all semester. I've been relying on the lectures. Exercises 4, 5, 1, and 5, 4. 6 and 97 of the textbook. I want to save this, make sure it is saved. Alright. How do I want to do this? Oh, I guess it's kind of a one-track mind here. You freaking open up the textbook and go find the problems. But this is a PDF. I seriously doubt we're gonna find the exact page number. Well, I say that. 480. There's 98. There we go. 451. Use the master method. It's actually the master theorem, but let's not split hairs here. Use the master method to give a type asymptotic bounds for the following recurrences. I don't even remember the master method, so let's do some review. We'll go to notes if I can find them. Would be master theorem, lecture 4. No worries, man. I know I'm kind of jumping straight into complex stuff here. It's not as simple as, you know, what is insertion sort? We actually had some of that earlier. Insertion sort's easy. Where is the definition? Let's start with that. Here. This right here, this middle notes chicken scratch, this is the master. If you have A of the running time of n over b plus a function of n, then the running time of n has the following running time bounds. That's what I can't even say it. Asymptotic or whatever it is. Which is basically, you know, what does the graph look like if you were to map it on a graph? If f of n is contained, that symbol always confused me as like what the word is contained in big O of log b of a minus some epsilon. For an epsilon greater than 0, then the running time is theta of n log b of a. Basically, I get it into this format and I prove either it's big O, it's big O, or it's big omega, I think. Let's just start with examples and we'll take it from there. All right, so. Come on, man. Copy paste. It's the problem with PDFs. That is the big problem with PDF. Dude, it didn't even copy it right. These are supposed to be parentheses. You know what? I'm just gonna write it. I have the abbreviated version of the toolbar, so I can't find one. And I would like that to be A. Perfect. All right, so the running time equals 2 times the running time of running time of divided by 4 plus 1. We'll start with that. Switch this to decimal points. That's the other problem with converting to a PDF is just formatting is all messed up. That to be there, probably fine. Okay, so going back to our notes, put this over here. I'd really like to scroll, if scroll. I might just I'm gonna download these notes. I can't deal with this right now. It's too much for me. It's too complicated. Go away. I don't. Thank you. That's what I wanted right there. Actually, I prefer this to be a little bit. Alright, so we have to prove. So, okay, so first we gotta define what A and B is. And then we can determine if it fits one of these three conditions, basically. So A and B is pretty simple in this case. A is 2. B is 4. Then we have to prove whether it's one of these, basically. Well, honestly, I can already see some of this, for instance. Oh, shoot. In log, what is that? Log 4 of 2. Oh, f of n. So if 1. Okay. So what we're doing, I see. I'm missing a term. F of n is 1. Because this right here is f of n. And then this is your AB and your runtime here. So basically, if how does in log, I know I'm just screwing up here. How does in log b, which is b is 4, of, thank you. These crackers or what? Well, they're yummy. Yeah. Okay, so how does n log 4 of 2 compare to, I'll just do question mark, to 1? Is n log 4 of 2 greater than, equal to, or less than 1? That's basically what the question is. And we know that n log 2 of 2 is 1. N log 2 of 1 is 0, if I remember correctly. So therefore, n log 4 of 2 is probably less than 1. We're just gonna just do this on the screen, that way you can see it. It's actually a really simple problem. Does that do log? Yes, it does. So, what is the actual value of log 4 of 2, basically? That's log 2 of 2. No, that's log 10 of 2, because it's a liar. I don't know how to do that on the calculator. We'll do it on Google. Log 4 of 2. Surely Google understands that. No, it doesn't. Base. See if it understands that better. Value of log 4 to the base 2. Wait, that's wrong. It's log 2 to the base 4. There we go. And then it just gives me the... I really wish it would just, like... log base 4 of 2. Please. How hard is it to come up with an answer? Log base 4 of 2. Answer, please. Just... Google is not helping me right now. Google hates me. That's what I'm going with right now. Google's just not being very nice. I need a tool to tell me what log base 4 of 2 is. Log 4 of 2 is 1/2. That's exactly what I thought. Which means that n of 1/2, okay, so write this in our lovely math algebra thing. N of 1 divided by 2. I'm assuming that's less than. That's gonna be that. Yeah, that's less than 1. There's no way that's 1 because n of 1 is 1. Right? No, n of 1 is n. Oh. Okay, I'm dumb. I'm dumb. N to the anything is greater than 1 unless n is 1, basically. So we know that n of 1/2 is greater than or equal to, we'll just be safe and say or equal to 1. We know that. What that means is that n to the 1/2 is actually omega 1 to some epsilon. Right? Yeah. And n of 1/2 plus some epsilon, we can say 1/2, where epsilon is 1/2, is greater than or equal to 1. That's a true statement. I'm positive that's a true statement. Where's my lecture notes? What am I doing? So because f of n is greater than the running time expression we have here, if they're for the kids, I would make them more bland, not less. So what I mean is that they should stay the same. Sorry. Got a little crackers my wife made, so I'm trying to figure out how to season them. Alright, so, again. That is wrong. No, that's right. Okay, so since f of n is less than. F of n is less than, and big O means less than. So since f of n is less than this minus some epsilon, and honestly epsilon can be anything. If epsilon is epsilon could be 1/2 actually. 1/2 minus 1/2 n raised to the 0th power is 1, I think. Even if it's not, like you can make it like 1/3 or 1/4, and that's still like 1/2 minus 1/4 is into the 1/4, and that's still greater than 1, or some n, you know, that exceeds 1. I'm pretty sure, right? Maybe I'm wrong about this. This inequality, I don't know the answer to this inequality. I have to think of this through. Is there a value of n and of epsilon? And we'll go up here and say minus. I actually don't know the value for epsilon, so I'm going to do this. I don't know about that either. I was going to put in a key code. We'll just say little e, even though little e means e, but we'll just say little e for epsilon. I lied. We'll do c. C is closer. So n to the 1/2 minus epsilon. Is there some value of epsilon subtracted from 1/2 in which n can still be greater than 1? That is the question that actually defines this problem. If the answer is no, there is no epsilon that makes n greater than 1, even though it's subtracted, or there's no value of n in which n can be greater than 1, regardless of what epsilon is, then the first case of the theorem fails. If this fails, then we should test the third case of the theorem. Right? Right. Is there some value of epsilon added to 1/2 in which 1 is greater than n? And then there's an extra condition here that would have to be evaluated if that's true. Okay, let's plug in some numbers. Let's say, even though epsilon can't be 0, let's say epsilon is 0, just for the sake of this. If epsilon is 0, n to the 1/2, can we make n large enough to be greater than 1 despite being raised to the 1/2? It's 0.5. I think the answer is no. It sounds weird, but I think the answer is no. I don't think there's any value of n that will actually get greater than 1. That's actually unexpected. I expected the first one to be the first case, you know, get you warmed up. Let's just do some ridiculous number. Raised to the... I hate when it does that. And then it won't let me go back. Raised to 1/2 again. Because, you know, there really isn't a choice here. It's still 0.5. It does not matter how much I increase n. If it's 1/2, it's 0.5. Okay. What if I do it less? Let's say epsilon is 1/2. Or no, let's say epsilon is 1/4, making our power to the 1/4. Now it's 0.25. That's not right. I'm an idiot. Okay, there's your proof. There is some value of n that gets greater than 1. So the first case is true. I wasn't hitting enter, and it was saying 1/2 because it was evaluating 1 divided by 2, which is obviously 1/2. So we have found a value of n in which you can get over the value of 1, and in this case, epsilon is 1/4. So 1/2 minus 1/4. That's an epsilon greater than 0. And that means the function, which is 1, is less than or equal to a log b to the a minus c. Okay, so that this inequality here is greater than or equal to for epsilon. I don't know the key code. Let's be fancy here. Alt 238. For some epsilon. Or I mean that's the answer. So solve that. Haha. I'm so smart. It only took me forever to do something that probably wasn't that hard. Alright. Second problem. Probably. This is 4.5-1. Needs to be late somehow. Seriously? Really gonna be like that? I swear this formatting is awful. That's dumb. Thank you. After. We don't need any indentation at the end. Okay, thanks. But I would like you to match. Like, is that... Why is that so hard? Why is formatting so flippin' difficult? Don't ever convert PDFs to Word. Just don't do it. It's not worth it. There we go. This might help. Probably not, but maybe I'll get lucky. I don't want a left indent. I want a 0 indent. But that does that if I do 0. Whatever. I'm done. I'm done trying. We'll just keep going. Push on through. Alright, second problem. P of n equals 2 P of n divided, what is that? Divided by 4? Plus the square root of it. I'm sure there's a square code, but I'm not going to look it up. I'll just say square root. My professor can't be too mad at me for that. That and 2 bullets. Yep, perfect. Formatting's actually working for once. It's a miracle. I do need restream chat. It actually bothers me that the visibility of restream chat is just... So we'll pull it up. Okay. I apologize if I missed your chats before. I should be able to see it better now. Okay, so same thing. Define our A's and B's. A is 2. B is 4. And our function is square root of, which means that we have an n log 4, which is n 1/2 minus epsilon. All this is true still. What isn't true is our comparison. Square root of n. Which is the square root of n 1/2? Or is it -1? What do they call it? Exponent? I was right. Square root is 1/2. This makes it very easy because square root of n. Here, I'm gonna have to do a new line for that. But that makes it extraordinarily easy. SQRT n equals n raised to the 1/2. What we're seeing here is take out the epsilon first. So our T of n is 1/2. There they are. Okay. So we know that f of n is n to the 1/2. And we know n to the log b of a is actually n to the 1/2. That means they're equal. What that also means is this is case number 2. Because that's what big theta means, is that they're equal. So that means that, and actually I didn't put in my final answer. I'll have to change a, but that means that f of n really. Is just say this. I mean, like, I don't know how else to put it. F of n is equal to, because I don't want to find that character. Theta, what is theta? It's either 2, 3, 4 or 2, 3, 3. That's omega 2, 3, 3. Here we go. Is theta of n log b. Oh, actually. Yeah, so that's answer. Which means given is, I know I'm saying equal. Hopefully he doesn't get too picky about that. Theta of n to the 1/2 because I'm lazy. Times log n. Easy one.
Excuse me?
That's the easy case. I'm betting you problem C is going to be case number 3. Just because that's how textbooks like to work. So, problem 3. Or problem C, whatever you want to call it. E of n equals 2 e of n divided by 4, because we like to keep the same thing. Wow, they make this quite easy. 4. That will allow us to redo some work here. That means that A is 2, B is 4, and F of n is just n. So the question then, how does this relate? So we know that this already. We don't really have to analyze n. That reminds me, I didn't finish A and I'm gonna forget. Let's actually jump back and write our answer for A correctly. So 1 is big O of n to the 1/2 minus some epsilon, which I believe was 2 to 8. A. Therefore, E of n is theta of log B of A, which is n to the 1/2. So again, the difference between big O and big theta, big O is effectively saying that big O is, the function inside big O is greater than the other function, whereas theta effectively says that the function inside big theta is equal to the other function. There's our official answer. Like, this is our official answer, and so we can go back down to C here. So the question is n to the 1/2 minus some epsilon greater than n? And the answer is no. You cannot take the square root of n and expect it to be greater than n. That doesn't make sense. So second case is n equal to n to the raised to the 1/2. Again, the answer is no. So now we have to evaluate the third case. Is n greater than n to the 1/2 plus some epsilon? So if I were to set epsilon greater than 0, let's say 1/2. No, let's say 1/4 again. So if n plus 1/2, if n raised to the 1/2 plus 1/4, which would be like n to the 3/4, is that less than n? And the answer is yes, it would be. There is some theta, or not some theta, there is some epsilon that exists in which n would be less than, or n to the 1/2 plus that epsilon would be less than n. So I think, so tentatively, if we say epsilon equals 1/4, then n raised to the 1/2 plus 1/4 would equal n to the 3/4, which would be greater than, oh, it's less than, excuse me, which would be less than n. Therefore, f of n, so n, is omega 2, 3, 4 into the 1/2 for some epsilon. But there is a second condition that we now have to evaluate. And that is A times f of n divided by b less than or equal to some constant of f of n? That's what C stands for, just some constant. Is there a constant? It doesn't matter what it is. Oh, for C less than 1. Okay, so some constant where C is less than 1. Plug in the numbers. You know A is 2, so A, f of n divided by, well, f of n is, what, n? So substitute n for n over b, so n divided by 4. Which we can simplify to 2n over 4, which is 1/2 n. Which is, in fact, less than or equal to some c of n. F of n. So substitute f of n. F of n is n. Where c is equal to 4, because we like using the term therefore, because we're fancy like that. Therefore, t of n. Sorry, that was a little loud. You know what? I should just say is instead of equals. We'll just do. I seriously doubt he's that picky. Therefore, t of n is theta of n. One more problem left to go, and you know I'm betting this is going to be does not does not apply. That's going to be the answer here. I'm betting you that, because I was right. This is the first case, this is the second case, this is the third case, and I'm betting you D is does not apply. Which unfortunately means it'll be some longer calculation. So if I find my homework somewhere, which is homework here, I don't understand the formatting. You'll have to forgive me. T of n equals 2t of n n divided by 4 plus. Though this does seem very similar to the previous, to problem C. Seems very similar to problem C. So because we are very repetitive, A is 2, B is 4, and f of n is squared. I should need a hotkey for that. Let's see. That means that and start evaluating. So we know that n to the 1/2 minus some epsilon minus an epsilon is not going to be greater than n squared. It's just not. So that means I didn't realize I had a separate tab. That means that this is out. Because f of n is not less than n to the 1/2. So problem 1 is out. We know that f of n is not equal to, we know that n squared does not equal n to the 1/2, so problem 2 is out. I wonder if my professor is going to make me show these things. So the real question is problem 3. Is n squared greater than n to the 1/2 plus some epsilon, or epsilon greater than 0? Well, crap, that does sound like... Okay, so that one fits, right? So... How did I do this last time? We'll just copy this. I mean, this is literally the exact same thing. So this is true, except this, instead of being n, this is n squared. That's true. Which means that n squared is... But we still have that secondary condition we have to pay attention to. But just because n squared is omega of n to the 1/2 plus some epsilon, we have to determine the next one. So the next one is a... I'm going to go ahead and add this. And really, I'm going to combine this too. Just so that it's all one line and makes sense. We're going to do that same secondary evaluation here, where A is this, actually. Seems strange, though. Is it less than or equal to? I mean, it is, right? No. No, this is n over b. This is n squared over 2. The 1/2 n squared. What's that? Pencil. I mean, they're better, don't get me wrong. But is more salt healthy for the children? I forgot that I had a snack. Is 1/2 n squared less than or equal to, I'm going to put a question mark here so that we know, less than or equal to some c of f of n, which is f of n is n squared. Some c of n squared. Really? Don't capitalize. Using my so hard. The answer to this, I think, is yes, right? Because c still equals 1/2. And 1/2 is less than 1. It kind of gets me that, like, what am I missing? Maybe if, maybe if this were more of a polynomial or something. F of n over b, so n squared over b. No, it's n over b squared. That's what I'm getting wrong. This isn't n squared divided by 4. This is n divided by 4 squared. I got the substitution wrong. Which is n divided by 4 times n divided by 4. And expand this one more time. Or it's already expanded. Hold on. What that is, if we expand this, that's n squared divided by 4 times 4 is 16. Divided by 16. Which then expands out to 1/8? 1/8 n squared? So then this is still true. 1/8 n squared is less than or equal to c times n squared, where c equals, I say equals, it should be less than or equals, no? Where c is greater than or equal to, that's what it should be. Where c is greater than or equal to 1/8. Am I missing anything? 2 of n divided by 4 squared equals 2 of n squared divided by 16, which then equals 1/8 n squared, which is less than or equal to c of n squared. Actually, these parentheses don't need to be there. C of n squared, where c is greater than or equal to 1/8. That's right. That works. So the secondary condition evaluates true, which means that the third condition actually is true. I was wrong. We have a therefore here. Therefore, T of n equals theta of f of n, which is n squared. I really only wanted to be using... We're using music I didn't expect. I don't know why... Well, this is still wrong. Where's my playlist? I'll restart the playlist. I'm surprised I'm already over it. Shuffle. And we'll loop it. There. Oh wait, can't ever fail. Unless Nintendo took all of it down, but I don't think they did. Oh look. They exist. Alright, anyways, back to work. Therefore, T of n is theta of f of n. F of n is n squared. So yeah, that works. Cool. That's part A of problem 1. Easy. Oh, my legs hurt. Problem 4.5-4. 4 textbook. Hopefully this isn't that long. Can the master method, or master theorem, be applied to the reoccurrence T of n equals 4 T of n divided by 2 plus n squared log n? Why or why not? Give an asymptotic upper bound for this reoccurrence. Well, this is effectively this last problem. Instead of n squared, we got n squared log n. And I'm thinking it's gonna fail the secondary condition. Get our answer bullet points here. Then 4 2 plus A is opposite. Our A is 4. Crap, now we have to double check that. Our A is 4. That's different. Let's not get confused. B is 2. And then our f of n is this n squared. Okay. Right side. In log 2, log base 2 of 4 is probably 2. I'll have to double check on it. Seriously? No, I did that wrong again. Log 2 of 4. Right? Log B of A. That's the way the master theorem. Log B of A. Log B of A. That simplifies to... It's 2. I was right. Log base 2 of 4 is 2. Equals n squared. That actually simplifies things. I can already tell you there's an inequality here. N squared is not remotely close to n squared log n. Like it, okay, it's remotely close, but the point is there's no chance that they're going to be the same. And you'll see this. Okay. We have 3 conditions. Is n squared log n less than n squared? Answer is no, because log n, however small it might be, still adds on to n squared. So case 1 is gone. Case 2 is n squared the same as n squared log n? No, because of that log n again. So case 2 is gone. Is n squared log n greater than n squared? That is true. So we're going to be working with the third. Apparently I have to modify Stardew Valley on my wife's deck, so we're going to take a break real quick. All right. All you need to do is move.
No.
Only
this
need
is
to.
what I keep you around for.
I'm distracted doing homework. Your father says the salt is better. You know, I thought this was charged, but now it's not turning on. Very funny. Complex. Fuzzy math homework is boring. Call it fuzzy math because when you're dealing with computer science, asymptotic runtimes and crap like that, you can do some fuzzy stuff with inequalities. Makes you wonder if you're doing real math. It works out in the end. Like, it makes sense, but you can drop whole term. So like if you have a runtime that's n squared plus n plus 1, you can effectively drop the n plus 1 and say, oh, it's big O of n squared, and you're done. So it's fuzzy math. Whenever I feel like I'm done doing, I'm certainly not finishing homework tonight for the next one. Although it's almost midnight, so I might see how it goes. Love you. I could stream my wife's deck here. So I just need to literally move one file in Stardew and then verify she can log on to the Stardew server and done. This is technically her downloads folder. If you stick around for like 3 minutes, I'll be done. You can say hi to everybody. Fair enough. They're quite yummy. Yep. We'll see. We know how our son is. Nothing. Oh no, it's gonna break. Oh, I have a solution. Why can't I paste? Paste. Fine. I have to extract a zip file. So exciting. Go get popcorn. Not because clearly my math homework, which isn't really math, is much more exciting than watching me, you know, mod Stardew Valley on a Steam Deck. Why is it taking so long to copy this? Copy. Oh no, it's. Fortunately, I have to download one more mod. Stuff doesn't. That mod is something like Ace's Expanded Farming or something. M. Take a few more minutes. All right, so my plan is I'm gonna finish this. I'm gonna finish the last problem, and then I'll probably go to bed. By last problem, I mean this problem. I'll have to do. I don't know how I'm gonna finish this. My deadline's midnight tomorrow night. Maybe I do stay up tonight. Yeah, I do. Oh boy. Oh. I realized there was this many mods in a thing. I know, super boring. I'm sorry. I'm working. Start Stardew Valley for her, and hopefully. I try to scoot up. Let me see if I can. I think I can actually. That's better. Just wanted to get closer to the mic. Probably gonna have to do an invite code. I'll get to see my started character for like 3 seconds. If I say that. There you go. Fancy pants. I don't want an IP. Go back. It's gonna be a pain about this. How do I open up the keyboard? There it is. This is where people find out my Stardew Valley server name and come stream snipe me. Okay. HT4 RT Come on. There we go. Let's see if it loads. It looks like it's loading. Yes, it did. All right. Awesome. Okay. Very, very good. What the fuck just happened? What the fudge? I broke something. Look, I only have 44 mods. It can't be that bad, can it? Well, apparently it's that bad. I'll restart it and hope it doesn't happen again. I know I have kind of a jank jank setup. I might be able to cull some of those installed mods, but we'll see. It's for the best anyways. You guys don't need to see that invite code and stream snipe me. Okay, I'm breaking things. Alright, let's get down to business to defeat the Huns. Alright, back to homework. So, where were we? We determined that our big O, theta, omega testing ended up with n squared. And our f of n is n squared log n, basically. We determined that the comparison most likely to succeed is situation number 3, which is omega. So if we say that f of n, which is n squared log n, is greater than or equal to n squared, which that is a true statement. I'm gonna go ahead and make this clear. I don't think I've been made it clear in previous problems. Which means f of n is omega 4 of n log b of a. Actually, oh, hold on. There's the epsilon I didn't take into account. Epsilon has to be greater than 0. So, and honestly, this is the same as like n squared plus, or n squared times n epsilon. That's what it is. Is there some value of epsilon that is less than log n. That's ultimately the question. Is there some value of epsilon that's less than log n? And I think the answer is no. No matter how small n to the epsilon gets, it will never be smaller than log n. And greater than or equal to n to the epsilon. Or some value of epsilon greater than 0. I think the answer is no, in which case 3 also does not work. All right. There is no value of epsilon such that n to the epsilon is less than log n. Of n is not omega plus epsilon. Alright. Also know that word. Gosh, wow. Failing here. I have to explain each condition in order to justify my conclusion. So n squared log n is not theta of basically of n squared. And it's not big O of n squared. Wow, I'm big on here. It's getting late. Clearly I do need to take a break or something. All 3 conditions are false. The master theorem does not apply. Alright, next point. Still not done. No siree. It wants the asymptotic complexity. Give an asymptotic upper bound for this reoccurrence. Well, the asymptotic upper bound is we're gonna have to go back to the previous homework's notes, I think. I think the answer is going to be n squared log n, but I'm going to have to do the hard way. So this goes back to previous notes. roughly 2-ish weeks ago. For divide and conquer. Basically, we have some format. Where is it? Two t of n divided by 2 plus d. I could have sworn there were some equations I could plug and play here. I could actually be wrong. It's this one right here. It's like, this is the number of sub-problems. And you've got the number of splits, basically, and then your function for combining. And what it's doing here is... Oh, shoot. I'm blanking. I don't know how to find... Effectively, what it's asking for is for me to find what the big O of this is. I can already tell you because it's pretty obvious. The big O is probably going to be in... No. I'm betting the big O is going to be n squared log n. So we're going to have to reason it out. I don't want to reason it out. Oh, man. Yeah, except this example freaking... This is a ball master thing. Okay. So we have a running time of 4 e of n divided by 2 plus n squared log. Right? So the height of this recurrence tree, effectively, log n divided by 2, so the height is log n. That's a true statement. We know that each sub-problem has double the number. Dada, okay, that sounds like I'm gonna have to hang up. Alright, guys. Thank you for your time. I'm gonna go ahead and kill my stream because apparently my daughter needs me. Yeah, I hope you have a great day, and with luck, I will see you next week. So, bye.